A warm welcome to all of you. Uh, Today we are going to see about the basic things behind what is DBMS. So we are going to see about the basics of DBMS along with its architecture in this lecture video. Coming to the lecture video, myself R. Narendran, working as assistant professor in the Department of Information Technology in Erode Sengundar Engineering College. Okay, over to the PPT. So today we are going to see about the outline structure of DBMS. What is the need of DBMS? What are the data models? And what is the meaning of relational database management system? And how the data are stored and processed along with its architecture. So coming to the basics of DBMS. So particularly, what is DBMS? So it is a collection of interrelated data. So the data can be of any form. For example, it can be a set of programs that are used to access data also. Or it can be an environment that is both convenient and user friendly, which can be effectively used by the user. So basics of DBMS. So in this, the real-time applications. Okay, the real-time applications of DBMS are banking sectors, where transactions are being carried out, and airline reservation systems, train ticket reservation systems, bus ticket reservation systems, and university registration and grade updation. Enterprise application also we can use. So here the customer, product, and purchase details can be processed. Coming to the online retailers, we can able to track the orders, we can able to purchase the orders, we can able to customize the order tracking system effectively by means of user recommendations. So that is, for example, Flipkart online registration or Flipkart, Amazon, these kind of platforms. So we can able to maintain the records of employee details, their salary details, and what are the deductions made for that particular employee by means of these kind of enterprise applications. So basically, the database will be very large, and it can be used with the help of management system that can be effectively used in the day-to-day life. Considering the university database, here the database is being processed, and the data is processed for students, instructors, and courses. For example, when you see this particular database table, it consists of ID, name, department name, and salary. So we are in need of processing each and every data and accumulate this particular data in a particular format, so that it can be manipulated in the upcoming transactions. So there are certain drawbacks for using these kind of file systems in the database storage. For example, it can be data redundancy, and inconsistency. That is, multiple data is being processed and multiple data are stored in a different types of format also. So, and it is difficult to access that particular data. So we need to carry out this particular task by means of writing a new program also. So data isolation, it is unable to isolate the particular data effectively because multiple files are being processed, and each and every file is being processed in a different way. There is an integrity problem also that we are in need of remembering. So atomicity of updates. So failure may leave database in an inconsistent state, which is with a partial update. For example, if you are taking a amount from the ATM machine, and suppose the amount is not withdrawn, but you are getting a message as the amount is being dispatched, that is withdrawal. So in such cases, we going to handle this by kind of atomicity of updates. So next one is a security problem. It is very hard to provide user access to some kind of that particular data. So coming to the relational database model, here everything is constructed in the format of tables. That is, it consists of rows and columns, which contains entity and attributes. Yeah, here we are having two types of tables. In the first table, you are having ID, name, department name, and salary. And in the second data, we are having department name, building, and budget. So data definition language, it is nothing but it's a normal database schema, which is processed by means of queries. For example, create table instructor. Instructor is the table name, and within the table, you are going to process four different types of data. So these data are ID, name, department name, and salary. So ID is nothing but the data. Which is representing the particular instructor, that is represented in character, and name and department name are represented in varchar data type, which is having 0 to 20 characters, and salary is in the format of a numeric data type. So behind this, there is an integrity constraint which is stated by primary key, secondary key, or foreign key. There is an authorization part where you can grant access or revoke certain kind of access of particular data to a particular customer. So next one is data definition language, data manipulation language. It is a query based language. There are two types of languages of handling queries we are used. So one is pure form, and this is, and another one is the commercial form. Pure form is providing properties about computational power and for optimization. That is a relational algebra, tuple relation calculus, and domain calculus. So whereas commercial applications are nothing but it's a SQL based queries, that is structured query language. SQL is nothing but a commercial language which is widely used and is a form of structured query. So we can apply this particular thing to the embedded SQL also. We can use it with the interfaces such as ODBC, JDBC connectivity. Coming to the architecture, which is the main part in the presentation today. So there are four different types of database that we are running: the centralized database, client server based database, and parallel, that is multiprocessor database, and distributed database. So coming to the history of databases, it starts from 1950s and 1960s. We are storing every data in the form of magnetic tapes, which is of very small quantity of storage. So it can be accessed by means of sequential access only. Afterwards, punched cards were being accessed. So there will be a punched tapes which is given as input to the machine. So it reads the data according to the pits and holes. Afterwards, in 1960s and 1970s, hard disk and network-oriented data models were being widespread throughout the world. So, and a number of prototypes are being introduced, and transaction processing has been begun. In 1980s, research-oriented relational prototype are used for commercial purposes, and object-oriented database systems has been flourished. In 1990s, where the websites and the internet are being currently introduced, so there is a large need for data warehouse. So large multi terabyte of data warehouses are being stored, and in early 2000s, automated database management system has been introduced. In the latter 2000s, number of companies such as Google, Yahoo, Amazon has been commercialized, and they took over the particular DBMS part. Coming to the architecture of DBMS, here is the architecture you are going to see. So it is split into three different tiers. Tier one is the DBA, user and application program part, which is called as a user interface part. Tier 2 is the database management part. It consists of a data dictionary manager and command processor, transaction manager, buffer manager, scheduler, and integrity checker. And tier 3 is having the part of database management files, which can be a raw file or a different types of files. So this is a three-tier architecture, and we are going to see a lot more thing what are the data flow in this particular architecture in the upcoming sessions. Until that, stay tuned. We will see in the next video. Thank you for listening. Thank you once again.